Okay, I'm rather dissatisfied with that last video, so we're going to try to repeat things in this kind of order. We got a phasing rotation in time. The top coil has its magnetic field on the 3-coil assembly coming out first. The second coil has its magnetic field coming out second in time. The third coil has its magnetic field coming out third in time, according to the commands of the line inputs. Now what we're going to do then is we're going to remove the commands of those line inputs. So we're going to show the system assembled as is with everything working. First thing we're going to do is we're going to take out the bottom coil on the 3-stack, the third one in succession. We're going to take those wires out of the circuit, leave them open. Then we're going to do the same thing for the second coil. We're going to take those line connections out and leave them open. And then we're going to take the connections on the top coil and we're going to open that circuit by the amperage meter means, which we tried to use last demo. Then we're going to look at the state, the unloaded state of the 9 voltage meters. Then we're going to be reassembling everything. But when we reassemble, what we're first going to do is we're going to show the short on the second coil, the short on the third coil. Then we're going to take the short off the second coil and give it its lines connections. And we're going to take the short off the third coil, give it its lines connections, and then we'll be right back from where we started from. And only in one of these situations does the voltage Q factor come up to a combination near 500 in order to be able to light that neon. So we'll go in there and turn that on and start describing things as we tear it apart. And every time we tear something apart, we need to have a 9 voltage meter reference to determine any kind of time distortion going on. But we also need to show the components that are in fact being disassembled by their respective amperages. The first thing that we're going to disassemble is the amperage of the 68.5 Henry coil, which in turn, through its mutual induction with the flux capacitor, powers a 4th resonance. We're not going to fool with the 4th resonance. We're just going to go 1, 2, 3, eliminate them all down the line, short them down the line, and then reconnect them back up. Well, we'll go turn that on then. With no field. We can see the neons lighting. We're going to go in there and we're going to look at what's going on in that situation. We have about, oh there it is, 2 milliamps, and the extra coil has about 1.6 milliamps. We'll go ahead and disconnect that neon for making our observations at least, if we can. Disconnected the neon, that's the pre-vibrational state. Obviously, since we took the load off, those quantities are going to go up. They're 1.8 on the third resonance, 1.8 milliamp, and 2.25 milliamp on the extra coil resonance, not connected to the lines. It's powered simply through induction through the chain of command. There's the amperage on the meters, but we've got to get to work here. Okay, we're looking here now. We're going to disconnect. Here's the 9 voltage meter state. It may be a little over 360 degrees. Now we'll leave that on the 9 meter state, and what we're going to do is go over there and open up 1-3. 1-3 is currently at 20.9 volts around in there. It's the bottom meter in the middle. So we've taken out the bottom coil resonance. Since we took it out, it's voltage went out. We're at 0 amps on its reading and its extra coil reading. Now we're going to go out, we're going to take out number 2. Number 2's voltage meter is 1-2, the red meter on the bottom. It's at 10.6 volts. And it's currently conducting 11.7 milliamps. And we know that's going to go to 0 once we take it out. So we'll go back to our 9 voltage meter reading. Or 6, pardon me. And we're going to keep an eye on 1-2. We're going to remove its load. This load's been removed. We've seen that shot up to 24 volts. Now we're going to, we see that the 2-3 meter, the remaining phase, the only phase being employed, now has 2.4 volts, making 7.2 milliamps. Now we're going to disengage that resonance also. There is our 6 voltage meter stake unloaded. Okay, we've seen that shot up to 14.8 volts. We're going to load it down now from 2-3, the third bottom meter on the right. (14-3) drop down to 2.4 volts. Now we're going to short out phase number 2. Just shorted out phase number 2. Phase number 2 is now producing 9-some milliamps through the air from the influence of phase 1, where phase 1's voltage went up to 11.1 volts, but to impart that amperage, its amperage delivery went down to 2 milliamps. Now we're going to short out phase number 3. Go back to our 9 meters. See that we're running out of time quickly. Now we've shorted out phase number 3. The only thing hooked up to the air is 2-3, producing 9 volts, enabling 3.2 milliamps, 3.4 milliamps from 8.8 volts. Phase 1-2 and phase 1-3 have not been hooked up to the lines. Instead, they're acquiring their power through the air. And we see that as they require their power through the air, the middle coil acquired 6-some milliamps. Third coil is acquiring only 0.67 milliamps, and the extra coil is procuring 0.69 milliamps. Doesn't look like we have enough time now to hook these up to the actual lines and show all that difference. We're going to have to stop.